Now, I've searched for direct neurological tasks that are looking at creativity directly, because so far we've just looked at face perception and motor action and emotions and so on. I've been sort of coming at this from a bit of a side thing, saying these are other things that people have said are localised in the right hemisphere, and the evidence for that is weak. We do see effects, but they're very small, 4 milliseconds, 7 milliseconds. What evidence is there that the right hemisphere actually does creativity, and that creativity is stronger in the right hemisphere, and that therefore perhaps creative people might make more use of the right-hand side of their brain? And I can't really find any. I've got a couple of early studies here that I'll talk through briefly. And so actually, et al., we're trying to look at associations. So they would flash what's called a prime followed by a target. So you'd get one word flashing up and then another one. And they'd be linked to each other. So bank and money is quite a strong relationship. And so seeing bank speeds perception of the word money. Whereas when I do bank river, well, they're still related, aren't they? But it's a weaker relationship, subdominant they call it. And so does it prime river as strongly? The answer is no. And they argue that the ability to recognise these subordinate meanings is linked to creativity. People who see unusual uses, unusual associations, are more creative. And so if you've got some creative people, they should be faster at recognising these subordinate ones compared to the dominant ones. So they split people into 3 groups using a creativity test. So you have people who scored high on it, medium on it, and low on it, and asked them, this was the creativity test, name as many ways as possible in which an apple and an orange are alike. They're fruit, yeah. They're spheres, yeah. They're juicy, yeah. Creative people come on with many more things. You can use them to throw a policeman. Example, don't do it. Okay. Just an example. That would be a creative use of an apple and an orange. The uncreative people just got stuck at 3 or 4. So this was the experiment. They also showed these primes only for 35 milliseconds. That's called subliminal. We'll come on to that in another lecture. It means they can't actually report what they're seeing. And long, 750 milliseconds, where they could see them and report them. And now we have some graphs. So we've got the short primes that they can't report, and the long primes that they can report. And we've got them presented in the right visual field, so that goes to the left hemisphere, or the left visual field, which is in the right hemisphere, and we're interested in. For the low creative group, there was no advantage, no priming here for the subordinate. Those white lines, white dots, they're flat. Okay? So it doesn't matter if you can see it or not. Whereas if you can see it, it's speeding up. Well, sorry, it's increasing the response for the dominant relationship in both hemispheres. So there's no hemisphere effect there. Whereas in the high creative group, well, now we've got no advantage for the dominant one in the right visual field, going to the left hemisphere, but we do have an advantage for the subdominant one, the white lines going up. So it's getting better, if you can see the word, in the left hemisphere. And if it goes to the right hemisphere, then we're getting, again, subdominant priming. We're also getting it for the dominant one. So here, what we should expect if the right hemisphere is responsible for creativity is we should get this effect for the subdominant in the right hemisphere. But we're not getting it in both hemispheres. Both hemispheres are showing priming for this subdominant relationship. And in fact, the linguistic superiority of the left hemisphere means we don't get priming for the dominant one. The second study I found, a bit more recent, 2004, Bectoreva, used a neuroimaging approach rather than just sort of doing reaction times. It's called PET, positron emission tomography, where they inject radioactive substances into the brain and measure where they go as your brain is processing things, and how the blood is taken up by your brain. And so this shows how your brain, which areas of your brain are using most blood in order to do your task. And they asked people to either create a story using unrelated words, which is really difficult, so that requires creative abilities, or a control task where all the words are related together, and it's fairly easy to come up with a story that links those words. They found increased activity not in the right hemisphere, but in the left hemisphere, comparing these two tasks. So this is the difference between the creativity task and the control task, the unrelated minus the related words. So this little dot shows roughly where it is. So over here you're looking at the head from the back, so it's there, and it's there, just there. That's where they found it. It's area 39, the left middle temporal area. It's associated in other studies with verbal working memory. Well, you have to remember what these words are. But also with task switching. That's where you have to keep hopping between different tasks. And so when you've got these unrelated words, well, you've got to keep changing between different interpretations of the meanings in order to see how you can link them into the story. So that sort of fits. But it's also associated with paranoid delusions. So the ability to be creative here is being linked to the ability to have paranoid delusions. Maybe creativity isn't such a good thing to train in our future leaders after all. They also did a word association task where instead of just being given the words, you had to make up words to link words that were shown in a list. So you'd have to make up some words to link glass and river. So you might go glass, reflection, water, river. Okay, so there's a semantic chain there. That's quite a hard task. A control task is just to list 5 items associated with each word. So for clothes, you might say shirt, socks, trousers, jumper, hat. So it's a category generation task. Now that's supposed to be a good left hemisphere thing. It's a linguistic, lots of facts. Whereas the right one should be, the top one rather, should be a right hemisphere task because you've got to come up with all these strange meanings. And again, they found only left hemisphere differences between these two tasks. Again, it's in an area associated with task switching, but also now with imagination and problem solving. These are, well, the problem solving is classically identified as a left hemisphere task, but imagination, well, in all of the pictures there, that was on the happy, colourful brain in the textbook, that was on the right-hand side in the stereotypical view. Not so. Here, we've identified it on the left hemisphere. And it's the left hemisphere that's carrying the difference between these tasks in both these cases. Now, a problem, of course, with all of these tasks is that they rely very heavily on verbal stimuli. Now, of course, we've seen throughout this lecture that verbal stimuli are best processed in the left hemisphere. So, of course, these tasks can only really show creativity benefits in the left hemisphere, because the right hemisphere isn't as good at generating the meanings of words. It has to wait for the left hemisphere to supply them to it. Then it can come up with the material, because it's connected. So these tasks, I don't think they're very good. Maybe, it's 10 years since that last one was done, maybe there's more out there now, and you can find evidence if you look in the literature that says, here's a pictorial creativity task, and there is now evidence that it's stronger active in the right hemisphere. But the evidence so far is quite weak. And in fact, throughout the literature on lateralization of function, there are definitely proven specific processes with strong right hemisphere advantages. As Gazzaniga identified, they are to do with all of those perceptual processing things that are not being interfered with by language. So, face perception, yes, we've seen it's faster in the right hemisphere in women for distressing baby faces and so on. But it's small. Colour naming, faster in the right hemisphere. Statistically significant. But the actual effect is small, it's in milliseconds. Musical perception, better if notes are played to your left ear and it goes all the way through to your right hemisphere. You can make finer discriminations more accurately and quicker. But the advantage is always very small. And the left hemisphere can do all these things too. So you mustn't think in terms of left brain doing things and right brain doing things. The left brain can do everything that the right brain can do. But the right hemisphere cannot do everything that the left hemisphere can do because it cannot do language and anything that relies upon language. And using the right hemisphere alone, as Compton showed, is always worse than using both together. That's why we have two hemispheres. They cooperate. They do things coherently. When you set them against each other, they interfere. But in the real life, we very rarely have tasks that put them into conflict, except when you get a psychologist trying to tell you to draw funny pictures, or someone asks you to pat your head and rub your tummy, as I saw some people do in that class. The brain works best as a whole. It's designed that way, not as two halves. And we do not really want to train future leaders to be chimpanzees.